Hey guys, we're going to take a look at chapter 7-4 today. It's called Properties of Similar Polygons. You can follow along on page 546. The good news is that this is pretty similar to 7-3. So if 7-3 was easy for you, this should be a pretty doable lesson. I have a couple of vocab words. The first one is similar polygons. It's just what it sounds like. Polygons that have the same shape but not the same size. So recall that similar means same shape but different size. So down below we have an example of a rectangle that's a 3 by 4 inch, and then another rectangle that is a 6 by 8 inch. So the final vocab word is scale factor, which you've heard before. Basically what we're trying to figure out is, hey, if these two are similar, what's the scale factor? Very similar to what we were doing in 7-3. So you're going to go ahead and write your ratio. Let's see here, let me color code this. I'm going to say that this length 8 inches corresponds with this length 4 inches. So there you go. And I'm going to say that this width of 6 inches corresponds with this width of 3 inches. So let's go ahead and reduce this. 8 divided by 4 is 2. 6 divided by 3 is also 2. So that's our proof that they're similar. Here's our scale factor. Scale factor is 2 in this case. So the ratio of the lengths of the two corresponding sides of two similar polygons. In other words, what did we multiply these dimensions by to get to these dimensions? Well, we multiplied by 2. 3 times 2 is 6. 4 times 2 is 8. Okay. Let's go ahead and take a look at example A, where you have two triangles, and really the name of the game here is you have to put like with like. Okay, so let's see here. I have AB is 8 and XY is 12. AC and BC are both 6. XZ and YZ are both 8. So I'm going to go ahead and write, I'm just going to write two different ratios here since the dimensions occur twice. The same dimensions occur twice. I don't need to do this 3 times. I can go ahead and just do it twice. Okay, so let's see here. So you want to figure out, what does 8 correspond with? Is that going to correspond with 8 or is it going to correspond with 12? Well, it's going to correspond with the longest side, which is 12. So let's go ahead and write a ratio. And recall that you're going to put the dilated over the original. Dilated over the original. So later in the alphabet is your dilated, original is earlier in the alphabet. So I'm going to put 12 over 8. Okay? And then let's see here, I'm going to put 8 corresponds with 6. So I'm going to put 8 over 6. Give myself a little more room. 8 over 6. Okay, so I can reduce some stuff here, right? And actually let me finish color coding this so you guys can make sure you see where all this comes from. Okay, so you can convert this to a decimal or a fraction. It doesn't really matter. If you reduce this down, let's see, I can divide both of these by 2, right? Actually, I can divide both of these by 4. Divide by 4, divide by 4. That's going to get me 3 halves, otherwise known as 1 1/2, right? 1 1/2, 1.5 if you prefer. Over here, I can't reduce by 4, but I can reduce by 2. So let's see here. 8 divided by 2 is 4. And 6 divided by 2 is 3. Oh. Well, let's see here. Does 3 halves equal 4 thirds? If you're not entirely sure, you could plug this into a calculator and get a decimal equivalent. Let me go ahead and do that. 4 divided by 3, That's going to be 1.3 repeating. 4 divided by 3. Yep. So that's basically 1 1/3, otherwise known as 1.3 repeating. So in other words, these are not equivalent ratios. 3/2 does not equal 4/3. So in this case, you're not going to say what the scale factor is because there isn't one. It says determine whether the two triangles are similar, explain. Well, they're not similar because they don't have corresponding sides. And this is your proof. So here's our final answer here. Not similar because 3/2 doesn't equal 4/3. Okay? So this is going to be an example of something you'll see in the homework. Some of them don't work out. You're just going to say, nope, they're not similar, and explain why. Okay. Let's see here. Take a look at example B and C. This is a slightly different problem. So there are two polygons. They have all of the angles, the arc marks listed in all the angles, and they have some of the side lengths. So let's see here. I'm going to do some color coding. This side length here, AB, is unknown, but we know that this one is 24. Okay. Let's see here. We know that AD is 13. But WZ is unknown, so maybe I don't want to compare those sides. I know that DC is 10 and YZ is 15. So what you want to do is you want to kind of identify a side length that is known for both. So 10 and 15 is known. They're asking you to figure out what WZ is. WZ. So that's going to be this side here. I'm gonna put that in blue, right? So this is the unknown. I'm not gonna call it X because X is already being used. You can call it any letter you want as an unknown. How about we just call, let's see, A, B, C, D, W, X, Y, Z. How about angle, side length L. I'm going to just call it L. It doesn't really matter. It's just a label. So I want to know what this is. I don't know what it is. So what you want to do is figure out with this shape, what's the corresponding side? Well, it's going to be the side that's between the angle that has one arc mark and the angle that has, is that 3 arc marks? Yep. So over here, you're going to see 1 arc mark and 3 arc marks. So it's got to correspond with 13. Okay, so you're going to go ahead and, just like before, remember you're going to start with the dilated image. Well, you know what, in this case, we're going to write 2 ratios. So it really doesn't matter what you put up top and what you put down below. What matters is that you have like across from like. So let's see here. I'm going to put 13 in the numerator. I'm going to put 10 in the denominator. Is equal to, okay, what's like with 13? Well, L, our unknown length. What's alike with 10? What corresponds with 10? 15. Okay, let me color code all this so you guys can make sure you see where it's all coming from. Like across from like. So this is shifting gears a little bit. Up until this point, I've had you guys put the dilated over the original. That's how you find scale factor. When you're finding a missing side length, you're going to write a proportion. And in the rules of proportion say you have to have like across from like. So if you want to put 10 equals 15 up top and 13 equals L on the bottom, that's okay. You're allowed to do that. Just make sure you have corresponding sides across from each other. Okay, so let's go ahead and multiply this out. 10 times L is 10L. And let's see here, 13 times 15. 13 times 15, we plug that in, is 195. Okay, so now we want to undo 10 times L, so do the opposite and divide. Go ahead and divide. And that is going to tell us that our missing side length is 19.5, right? If you're dividing by 10 here, you're just going to move the decimal point once. So L is 19.5. Okay, so let's take a look at AB. So let's see here, I'll use another color. I'll use pink. We don't know what this side is. We have to figure it out. What does it correspond with? Well, it's going to correspond with 24. So you can now go ahead and compare. When you're writing your ratio, you can use either the known orange lengths here, or you can use the known blue lengths, because we now know that this is 19.5. If you want to avoid using a decimal, then just stick with the two whole numbers for DC, which is 10, and ZY, which is 15. Okay, so again, I'm kind of running out of room for C. I'm going to put it over here. Go ahead and write your two ratios. It doesn't matter what goes on top and what goes on the bottom, as long as you have corresponding sides across from each other. So I'm going to call this, how about K? I'm just going to give it a random label. K is going to correspond with 24. And 10 is going to correspond with 15. Okay, so you can go ahead and finish. I'm going to color code these here so you can see where everything comes from. Go ahead and cross multiply. 10 times 24 is 240. And K times 15 is 15K. Go ahead and undo 15 times K by dividing. All right, so 240 divided by 15. 240 divided by 15 gets us a side length of 16. So K equals 16. Okay, so that's pretty much the name of the game for today. There are a couple of homework problems that might give you some trouble, so I want to get you started on those. First of all is number 6. It says the scale factor from the model of a human inner ear to the actual ear is 55 to 2. Okay? If one of the bones of the model is 8.25 centimeters long, how long is the actual bone in the human ear? So we have some stuff here. We have scale factor. We have the dilation. This is the dilated. And we have the original, which we don't know. The original is I said let it be X. Let X be the actual length. Okay, so here's your structure. Take your scale factor, multiply it by the actual length, and that's going to give you the length in the model, which we know is 8.25. So this is algebra, right? The unknown here is part of the question. So go ahead and solve for X here. So you want to undo 55 halves times 2. Well, obviously the opposite of multiply is to divide. How do you divide a fraction? Remember, everybody always forgets this one. Go ahead and make sure you multiply by the reciprocal. You're going to turn it into a multiplication problem and you're going to flip it. You could also convert this to a decimal. Let's see what we get. 55 divided by 2, 27.5. You could turn this into a decimal, 27.5, and then just divide like you normally would. That would be fine. Okay, so let's see here. These two cancel out, right? What you do to one side, you have to do to the other. 2 over 55. I want to be consistent. If this is a fraction, I want this to also be a fraction. So what do I put under it to make it a fraction? You're going to put a 1 under it. Okay, I'm going to let you guys finish it from here. Let's take a look at number 7. It says, refer to the graphic novel frame below. The brochure says the rope is 500 feet long. Use the properties of similar triangles to find the parasailor's height above the water. So the actual height. So I went ahead and I color coded this for you guys. This is the scale drawing, right? Where the rope is 2.5 feet and he's 2 feet above the water. Here's what's happening in reality. In reality, the rope is 500 feet long. We're trying to figure out what his actual height is. So you're going to go ahead and write yourself a ratio, a proportion, and go ahead and put like across from like, right? So the length of the rope's got to be across from the length of the rope. The height of the guy in the drawing has to be across from the height of the guy in reality. Okay, the spiral review, I just want to kind of remind you guys what you're doing here. So you're converting, you're figuring out what the scale factor for each drawing is. Here's the deal, is they're going to give you 2 different units of measurement. So before you start writing ratios, you need to convert so that they're in the same unit of measurement. So 6 inches on the drawing is equivalent to 12 feet in reality. Well, I want to convert 12 feet to inches. Well, there's 12 inches in a foot, so I'm going to say 12 feet times 12 inches tells me that in 12 feet there are 144 inches. So now that I have the same unit of measurement, I can go ahead and write my ratio. So 6 over 144, I can reduce that. Whatever you get here is going to be your final answer. Okay, this is going to be your final. There is a page in your book, I think it's in the very back, where it gives you, if you're not sure how many centimeters are in a meter, it's going to give you these conversions. So go ahead and look for that page, and that's going to help you with these. A lot of them are, feet and inches are going to be easier to deal with. Maybe meters and miles might be a little more difficult. So look for that page in, it's either in the front or the back. It might even be the inside cover where it gives you these conversions. Okay, guys, that's all I have for you for today. See me on Zoom tomorrow if you have any questions. I'll see you then. Okay, bye-bye.